Hi everyone and welcome back. So in the first video of this series, we start to build a schematic of the board. We saw how to make the appropriate connections for the voltage regulator. And in the second video, we will see how the voltage comparator works, why do we need it, and how to make the connections with the appropriate components. We will also make the reset session connections, which is used to restart the microcontroller. So let's get started. As I said before, the components embedded on the board, such as the main controller and the USB to serial converter chip, both are powered with 5V. I didn't mention before that the op-amp chip used to compare the voltage also is powered with 5V, which is this one here. And the Arduino board also supplied this 5V on his access pins, being able to power external components if he needed. This one here. I realized that in the first video I didn't explain how to pick the correct components that complement the topology of the voltage regulator that we are using, and if the pick of this IC is the right one for the requirements of the application. So let's do a quick view on his datasheet again. Here in the features we can see the main characteristics of the components. And what we have to do is link these characteristics with the Arduino board needs. And what do we know about these needs? Well, we are applying through the jack connector an input voltage with the range of 7 to 12 volts, or even more, being around of 20 volts maximum. And as we know now, the main processor, the USB to serial chip, and the op-amp are powered with 5V. And the Arduino board also provides this 5V to power external components. So we have to look if the voltage regulator that we are picking matches with our necessity of receive a maximum 20 volts on his input and step down to 5V. So let's look for these informations. Right here, operation to 20 volt input. That's perfect. And right here, fixed output voltage ranging from 1.5 to 12 volts, being 5 volts one of them. Okay, now we also know that a 1 amp of current is the standard current that supplies external components that are powered from the access pins of the Arduino board. Most of the embedded systems works with the current on range of milliamps, so that 1 amp of current is one of the standard current that we apply on dev boards. So let's look for the information about the operating current of this IC. Right here, output current of 1 amp. So this peak is the right one. So you kind of have to look for these key informations. Now, which components complement the topology of the application that we are using? We are using this topology right here in the figure 1. And as you can see, it uses electrolytic capacitors. We are adding to the topology a diode to ensure that if something's go wrong and the current tries to flow back, that will not be possible. And one ceramic capacitor to filter out another frequencies. For the diode, we have to see if the nominal current matches with the maximum input current that is allowed on the regulator. Okay, right on the top of his datasheet. A reverse voltage of 50 to 1000 volt and a forward current of 1 amp. That's perfect. Okay, now the decoupling capacitors. We are using 47 microcapacitors, not 10, and 100 nano for the ceramic one. Okay, so that was the revision that I wanted to make with you. Now let's start talking about the voltage comparator. The function of the voltage comparator is to identify whether we are powering the board through the jack connection or USB input connection. I did some simulations here that I wanted to show you. This circuit is the voltage comparator. We have this voltage divider which is connected on the non-inverting pin of the comparator, and on the inverting pin I'm connecting a 3.3 volt which will be the reference for the comparator. We get this 3.3 volt from another voltage regulator which drops the 5 volts to this 3.3. So what the comparator does is compare the input voltage on his pins and output with the maximum or minimum voltage that we are supplying it. So if the voltage that I'm applying on the non-inverting pin is greater than 3.3 reference, on the output we will get approximately the positive voltage that I'm supplying the comparator. But if my input voltage is less than the voltage reference, the output will be approximately the negative voltage that I'm supplying this comparator, as you can see on the simulation here. And we also have this MOSFET here, which switches based on the output of the comparator. If I'm powering through the USB connection, the input voltage will be less than 3.3 reference, so the output will be close to 0. This is a PMOSFET, so he turns on when 0 is applied on his gate, so the current will flow and we will get 5 volt on his drain. But if we are powering through the jack connection, we have at least 7 volts applied on the voltage divider, which gets me a 3.5 volt as input voltage, which is greater than the 3.3 reference. And the MOSFET will get high voltage on his gate, then he turns off and the current not flow, and we get 0 volt on his drain. So that is how we know if we are powering the board through the jack or USB connector. Okay, now that I explained how it works, let's continue building our schematic.